Okay. Our mission today is to kind of walk through how WinderCam gets you from just an idea, your shape, all the way to that usable G code, like from idea to G code in, well, maybe not 5 minutes, but pretty fast.
You begin at the Start tab, basically session management. You can save, load your work, clear it.
Or load examples, I guess, see how it works.
Exactly, or load an example. Then, first real step, the mandrel tab. This is all about your shape.
Okay, so here's where I'd like import my file.
Yep, import the mandrel data. And there are tools there too, like scale and transform.
Got it. Mandrel's in. What's next? The coil tab.
Right. Now we calculate the initial fiber path. This is where it figures out the ideal geodesic coil.
Geodesic. Like the shortest path on a curved surface.
Kind of, yeah. Think of it like stretching a string tight over the shape. You need to give it some starting info, like the pole radius.
Where the winding starts near the ends?
Essentially, yes.
Yeah.
And the width of the tape you're using.
Okay, makes sense. Then I click Generate Coil.
You click Generate Coil, and boom, you see that path visualized right there on your 3D mandrel.
That must be pretty helpful just to see if it looks right initially.
It is. But here's a key thing. That perfect geodesic path, it often doesn't quite work for real-world winding.
How so?
Well, it might not give you continuous winding, or it might miss spots, especially on tricky shapes. The fibers might lift off or slip or bridge across concave areas.
Ah, okay. So the perfect math isn't perfectly manufacturable.
Exactly. Which brings us to the crucial next step, the correction tab.
Right. So here you actually adjust that ideal path. Deliberately make it non-geodesic.
Precisely. You deviate slightly to ensure better continuity, full coverage. You select something called a convenience value.
What does that do?
It sort of influences the pattern structure, how the layers interlace, and there's an option for mesh structure if you're making lattices.
Okay, and does it give you options for this correction?
Yes. It calculates a whole table of possible correction variants.
So select that row.
Select it, hit Correct Coil, and the system adjusts the path. Now, it's a non-geodesic path, but one that should actually wind properly.
Fascinating. So you trade mathematical perfection for manufacturability. Makes sense. All right, corrected path ready. Next up, winding.
Yep. Now we generate the actual machine motion, the trajectory.
Translating that corrected path into X, Y, Z and rotation movement.
Exactly. The 4 axes. You set final things like safety R just to clearance distance.
So the roller doesn't crash into the part?
Right. And the G-code length, which is basically how many winding cycles you want the program to include.
And then click winding.
Click winding. And this is cool. You get a visualization, an animation. You can see the path, the first coil going down where it first touches.
Oh, wow. Like a preview of the machine running.
Exactly. You can watch the whole simulated winding process.
That's brilliant for catching issues beforehand. And then the main event.
The download CNC button. That gives you the G-code file.
We're ready to load onto the machine controller.
Yep. Though, formats can vary slightly.
Good point. Okay, almost there. Last tab is thickness.
You click Get Thickness.
And it calculates the material thickness profile based on the winding. So let's recap. You start with your shape, import it, calculate an ideal path, then critically correct that path so it actually works for winding, ensuring coverage.
Right.
Then generate the specific machine movements, visualize it, and download the CNC code. Plus, get thickness data for analysis or multi-layer winding.